Silent dance of the aurora. The night sky holds many quiet wonders, and among them is a gentle curtain of light that appears in the highest reaches of our atmosphere, far above the clouds and weather, far above the places where birds fly. This light moves slowly, shifting and swaying like fabric caught in a breeze that cannot be felt from the ground. It appears in colors that seem almost impossible, glowing against the darkness with a softness that feels as though it belongs to dreams rather than the waking world. This is the aurora, a phenomenon of light and atmosphere, of particles and magnetism, of the sun and the earth working together in a dance that has been happening for as long as our planet has had a magnetic field. The aurora appears in two places on Earth, one in the far north and one in the far south. In the northern hemisphere, it is called the aurora borealis, and in the southern hemisphere, it is called the aurora australis. Both are the same phenomenon, occurring at opposite ends of the planet, mirror images of one another separated by thousands of miles of earth and ocean. The aurora borealis dances above the Arctic regions, above Alaska and northern Canada, above Iceland and Greenland, above the northern parts of Scandinavia and Russia. The aurora australis appears above Antarctica and the Southern Ocean, sometimes visible from the southern tips of South America, Australia, and New Zealand. These lights appear most often in regions near the poles, where the Earth's magnetic field lines converge and dip down toward the surface. The Earth is surrounded by an invisible magnetic field, a protective bubble that extends far out into space. This field is generated deep within the planet, in the core where molten iron moves and flows, creating electric currents that in turn create magnetism. The magnetic field surrounds the entire planet, stretching out into space and forming a shield that protects us from the constant stream of particles flowing out from the sun. This stream of particles is called the solar wind, and it travels through space at tremendous speeds, carrying with it pieces of the sun itself, tiny bits of matter that would be harmful to life on Earth if they reached the surface in large quantities. The solar wind flows outward from the sun in all directions, a constant river of particles moving through the emptiness of space. When these particles encounter the Earth's magnetic field, most of them are deflected, pushed aside and sent flowing around the planet like water around a stone in a stream. But some of these particles are captured by the magnetic field, drawn along the invisible lines of force that curve down toward the poles. These captured particles spiral along the magnetic field lines, traveling from space down into the upper atmosphere, and it is here, when they collide with the gases in our atmosphere, that the aurora is born. The atmosphere is made up of different gases, mostly nitrogen and oxygen, the same gases we breathe at the surface but spread much thinner at high altitudes. When the particles from the solar wind collide with these atmospheric gases, they transfer their energy to the gas molecules, causing them to become excited. An excited molecule is one that has absorbed extra energy, and it cannot hold onto that energy forever. After a brief moment, the molecule releases the energy as light, a photon that travels outward in all directions. When billions and billions of molecules do this all at once, the result is a glow that can be seen from the ground, a curtain of light hanging in the upper atmosphere, shifting and changing as the particles continue to arrive and the collisions continue to happen. The colors of the aurora depend on which gases are being struck and at what altitude the collisions are taking place. Oxygen produces green light when it is struck at lower altitudes, around 60 to 150 miles above the surface. This green is the most common color seen in auroras, a pale luminous green that glows softly against the darkness. At higher altitudes, above 150 miles, oxygen produces red light instead, though this red is often faint and difficult to see with the naked eye. Nitrogen produces blue and purple light, and sometimes pink, adding different hues to the aurora's palette. The exact colors visible on any given night depend on the strength of the solar wind, the composition of the atmosphere at different altitudes, and the sensitivity of the human eye in darkness. The aurora does not appear every night, and it does not appear with the same intensity when it does appear. There are times when the aurora is barely visible, a faint glow on the horizon that might be mistaken for distant city lights. There are other times when it is brilliant and active, filling half the sky with curtains and rays of light that move and shift with surprising speed. The intensity of the aurora is connected to the activity of the sun, to the strength of the solar wind and the frequency of events on the sun's surface that send extra particles streaming out into space. The sun is not a calm, unchanging sphere of light. Its surface is constantly moving, roiling with energy, covered in regions of intense magnetic activity. Sometimes these regions produce solar flares, sudden bursts of energy and radiation. Sometimes they produce coronal mass ejections, enormous clouds of particles that are thrown out from the sun's atmosphere and sent speeding through space. When one of these clouds of particles reaches Earth, usually 2 or 3 days after leaving the sun, it can cause a geomagnetic storm, a disturbance in Earth's magnetic field that allows more particles to enter the atmosphere. During these storms, the aurora becomes brighter and more active, and it can be seen farther from the poles than usual, sometimes appearing in skies where it is rarely seen. The movement of the aurora is gentle and flowing, like curtains swaying in a breeze. The curtains are made of light, hanging vertically in the sky, often aligned roughly north to south. They ripple and wave, brightening and dimming, sometimes folding over themselves or spreading out across a wider area. The motion is not fast, but it is constant, a slow dance that can hold the attention for hours. Sometimes the aurora appears as arcs, long curved bands of light that stretch across the horizon. Sometimes it appears as rays, vertical shafts of light that seem to reach down from high above toward the earth. Sometimes it appears as a diffuse glow, a soft luminescence spread across a large area of sky without distinct structure. Watching the aurora is an experience that requires patience and stillness. It requires being outside in the cold, often in the deep cold of winter nights near the poles, standing or sitting quietly while the eyes adjust to the darkness. It requires looking up, letting the gaze drift across the sky without focusing too hard on any one spot, allowing the peripheral vision to catch the subtle movements and changes in the light. The aurora is quiet. It makes no sound that can be heard from the ground. There have been occasional reports of faint noises associated with very strong auroras, but these are rare and not well understood. For the most part, the aurora is a silent phenomenon, a visual display unaccompanied by any auditory component. The best time to see the aurora depends on where you are and what time of year it is. Near the poles, where the aurora appears most frequently, the summer months are filled with continuous daylight, and the sky never becomes dark enough to see the aurora even if it is present. The winter months bring long nights, sometimes with the sun never rising above the horizon for weeks or months at a time. These long dark nights are the best time for aurora viewing, though the extreme cold can make it challenging to stay outside for extended periods. In regions farther from the poles, the aurora is visible more often during the months around the equinoxes, in March and September, when the Earth's magnetic field is oriented in a way that allows more particles to enter the atmosphere. The aurora does not appear only at night, technically. During the day, the collisions between solar wind particles and atmospheric gases continue to happen, and the aurora continues to glow. But the light from the sun is so much brighter than the aurora that it cannot be seen during daylight hours. Only when the sun is below the horizon and the sky is dark can the aurora's faint glow become visible against the blackness of space. Different cultures around the world have observed the aurora for thousands of years, and many have developed stories and beliefs to explain it. Indigenous peoples living in the Arctic regions have watched the aurora throughout their history, and it appears in their oral traditions and spiritual beliefs. Some groups believe the aurora was the spirits of the dead dancing in the sky. Some believed it was the spirits of animals moving across the heavens. Some saw it as a bridge between the world of the living and the world of the spirits, a pathway that souls could travel. Some believed the aurora was a sign of coming change, of shifts in weather or fortune. These stories were passed down through generations, part of the cultural knowledge that helped people make sense of the natural world around them. In Norse mythology, the aurora was sometimes associated with the Bifrost, the rainbow bridge that connected the realm of humans to the realm of the gods. The shifting colors of the aurora and the way it seemed to stretch from earth to sky made it easy to imagine as a bridge between worlds. In Finnish folklore, the aurora was called revontulet, which translates to fox fires. According to legend, a magical fox ran through the snow in the far north, and its tail brushed against the snow and sent sparks flying up into the sky, creating the aurora. These are gentle stories, ways of understanding a phenomenon that would not have a scientific explanation until much more recently in human history. The scientific understanding of the aurora developed slowly over centuries. Early observers noted that the aurora seemed to be connected to magnetism, that compass needles would sometimes behave strangely when the aurora was particularly active. In the 18th and 19th centuries, scientists began to study the aurora more systematically, recording when it appeared and trying to understand what caused it. The connection to the sun was suspected but not proven until the 20th century, when advances in understanding of the sun's behavior and the development of instruments that could detect particles and magnetic fields in space made it possible to see the whole picture. The aurora occurs on other planets as well, not just on Earth. Any planet with a magnetic field and an atmosphere can potentially have auroras. Jupiter has auroras, brilliant displays of light near its poles that are even more intense than Earth's because Jupiter's magnetic field is much stronger. Saturn has auroras too, and so do Uranus and Neptune. Even some of Jupiter's moons have auroras, created by interactions between Jupiter's powerful magnetic field and the thin atmospheres of the moons. These auroras on other worlds are studied by spacecraft, which can observe them in wavelengths of light that are not visible to human eyes, building up a picture of how these phenomena work throughout the solar system. On Earth, the aurora appears in an oval shape around each magnetic pole. This oval is called the auroral oval, and it expands and contracts depending on the strength of the solar wind and the level of geomagnetic activity. When the solar wind is calm, the auroral oval is small and confined to regions very close to the poles. When a geomagnetic storm occurs, the oval expands, and the aurora can be seen at much lower latitudes. During very strong storms, the aurora has been visible from as far south as the Mediterranean or the southern United States in the northern hemisphere, and from as far north as Australia in the southern hemisphere. These events are rare, but they are memorable for those who witness them, seeing the aurora in places where it is almost never seen. The height at which the aurora occurs is surprisingly high, much higher than clouds or weather. The lowest parts of the aurora, where the green light from oxygen is produced, occur around 60 miles above the surface. This is well above the altitude where airplanes fly, above the layer of atmosphere where weather happens, in a region called the thermosphere. The highest parts of the aurora can extend up to 200 miles or more, reaching into the very edge of space. Despite occurring at such high altitudes, the aurora can appear quite close when viewed from the ground, especially when it is directly overhead. The perspective makes it seem as though the curtains of light are hanging just above the horizon or just beyond the nearest hills, when in fact they are hundreds of miles away. Photographing the aurora has become popular in recent years, as cameras have become more sensitive and more accessible. A camera set up on a tripod with a long exposure can capture colors and details in the aurora that are sometimes difficult for the human eye to see, especially the red light from high-altitude oxygen, which is often too faint to be visible without photographic assistance. The photographs show the aurora in vivid greens and purples and reds, curtains and arcs and rays frozen in a moment of time. But there is something about seeing the aurora in person that photographs cannot quite capture, the sense of movement and presence, the way the light fills the sky and changes from moment to moment, the cold air on your face and the quiet of the night broken only by the sound of your own breathing. The experience of watching the aurora is often described as meditative, as peaceful. There is something about standing in the darkness and watching the slow dance of light overhead that encourages stillness, that quiets the mind and draws attention away from everyday concerns. The aurora does not demand anything from the observer. It simply exists, moving through its patterns without regard for who is watching or what they think. It is a reminder of the larger forces at work in the universe, of the sun's constant activity and the Earth's protective magnetic field, of the thin layer of atmosphere that surrounds our planet and makes life possible. The solar wind is always flowing, always streaming out from the sun in all directions. It has been flowing for as long as the sun has existed, and it will continue to flow for billions of years to come, until the sun reaches the end of its life and begins to change into something different. The Earth's magnetic field has existed for billions of years as well, protecting the atmosphere from being stripped away by the solar wind, creating the conditions that allow water to remain on the surface and life to flourish. The aurora is a visible sign of this ongoing interaction, a light show produced by the meeting of solar particles and atmospheric gases, a phenomenon that has been happening for eons and will continue to happen for eons to come. In the far north, where winters are long and dark, the aurora is a familiar sight to those who live there. It is not always remarkable or noteworthy, not always a cause for excitement. Sometimes it is simply there, a faint glow in the northern sky, part of the landscape of winter nights. On other nights, it is brighter and more active, and people step outside to watch it for a while before going back inside to the warmth. The aurora is woven into the fabric of life in these regions, part of the seasonal rhythm of darkness and light, cold and warmth, the long wait for the sun to return. In regions farther from the poles, where the aurora is less common, it is often seen as something special, an event worth traveling to see. People journey to Iceland, to northern Scandinavia, to Alaska and northern Canada, hoping for clear skies and active auroras. They stand in the cold, cameras ready, eyes turned upward, waiting for the lights to appear. Sometimes they are rewarded with brilliant displays that fill the sky. Sometimes they see only a faint glow, or nothing at all, the aurora hidden by clouds or simply not active on that particular night. The aurora cannot be predicted with perfect accuracy. Forecasts can estimate when conditions are favorable, when the solar wind is strong and geomagnetic activity is likely, but the exact timing and intensity remain uncertain until it happens. The colors of the aurora blend together in the sky, green merging into purple, purple fading to pink, pink giving way to green again. The boundaries between colors are soft and indistinct, not sharp lines but gradual transitions. The light is not bright in the way that a street light or a flashlight is bright. It is a gentle glow, luminous but not harsh, filling the sky without overwhelming the darkness. Stars can still be seen through the aurora, tiny points of light shining through the curtains and arcs, a reminder that the aurora is a phenomenon of Earth's atmosphere and not something occurring in deep space. The Earth turns on its axis, completing one rotation every 24 hours, and as it turns, different parts of the planet move under the auroral oval. A location that is under the oval in the evening may have rotated away from it by midnight. A location that sees no aurora in the early evening may rotate into the oval's path in the hours before dawn. The aurora is always present somewhere on Earth, as long as the solar wind is blowing, but whether it can be seen from any particular location depends on time, position, and the size of the auroral oval at that moment. The magnetosphere, the region of space dominated by Earth's magnetic field, is not a perfect sphere. It is compressed on the side facing the Sun, where the solar wind pushes against it, and it is stretched out on the side facing away from the Sun, forming a long tail called the magnetotail. This tail can extend for hundreds of thousands of miles, far beyond the Moon's orbit. Particles from the solar wind can become trapped in the magnetotail, and when conditions are right, these particles can be released and sent flowing down the magnetic field lines toward the poles, adding to the aurora's intensity. The magnetosphere is constantly shifting and changing in response to variations in the solar wind, expanding and contracting, releasing and capturing particles, a dynamic system that is never quite in equilibrium. The Sun goes through an 11-year cycle of activity, during which the number of sunspots and the frequency of solar flares and coronal mass ejections rises and falls. At solar maximum, when the Sun is most active, auroras are more frequent and more intense, and they can be seen at lower latitudes than usual. At solar minimum, when the Sun is quiet, auroras are less common and tend to be confined to higher latitudes. This cycle has been observed for centuries, recorded by astronomers who counted sunspots and noted their patterns over time. The cycle is not perfectly regular, and each solar maximum and minimum is slightly different from the one before, but the overall pattern repeats, a rhythm driven by the dynamics of the Sun's magnetic field. Indigenous peoples of the Arctic have many different names for the aurora in their languages, reflecting the importance of this phenomenon in their lives and cultures. In some Inuit languages, the aurora is called Iqsaaniyat, a word that has been translated in different ways but often carries connotations of something that is playing or dancing. The aurora was seen as animate, as having agency and movement, not just a passive glow but something active and alive in its own way. Some traditions held that whistling at the aurora could make it come closer, or that clapping hands could make it dance more vigorously. Other traditions warned against whistling or making noise, believing it could attract the aurora's attention in unwanted ways. These beliefs varied from group to group, from region to region, part of the diverse tapestry of human understanding of the natural world. The southern aurora, the Aurora australis, is seen by far fewer people than its northern counterpart, simply because there are fewer landmasses and fewer populated areas in the far southern latitudes. Antarctica is largely uninhabited except for research stations, and the southern tips of the other continents are far from the auroral oval most of the time. But the Aurora australis is every bit as beautiful as the Aurora borealis, displaying the same colors and patterns, the same gentle dance of light against the darkness. Researchers stationed in Antarctica sometimes have the opportunity to watch the Aurora australis for extended periods during the long Antarctic winter, when the sun does not rise for months and the sky is dark around the clock. The study of the aurora has contributed to our understanding of many other phenomena in space and atmospheric science. The same processes that create the aurora are related to processes that can affect satellites in orbit, that can interfere with radio communications, that can induce currents in power lines and pipelines on the ground. Understanding the aurora helps us understand space weather, the term used to describe the changing conditions in the space environment around Earth. Space weather can have practical effects on modern technology, and agencies around the world monitor the sun and the solar wind to provide warnings when conditions are likely to produce geomagnetic storms and increased auroral activity. The aurora is a connection between the sun and the earth, a visible manifestation of the invisible forces that link our planet to its star. The sun's energy reaches Earth in many forms, as visible light that warms the surface and allows plants to grow, as ultraviolet light that creates the ozone layer in the upper atmosphere, as particles in the solar wind that create the aurora and shape the magnetosphere. The Earth responds to all of these inputs, absorbing energy, deflecting particles, maintaining the delicate balance that makes life possible. The aurora is a small part of this larger story, but it is the part that is most directly visible to the human eye, a reminder that we live on a planet that is constantly interacting with its cosmic environment. Sitting in the darkness and watching the aurora, there is a sense of time moving slowly, of being present in a moment that is connected to all the moments before and all the moments to come. The aurora has been appearing in the sky since long before humans existed, and it will continue to appear long after we are gone. The particles from the sun and the gases in the atmosphere have been performing this dance for billions of years, creating light in the darkness, painting the sky with colors that have no purpose other than to exist. There is no message in the aurora, no meaning beyond the simple physical processes that create it. And yet it feels meaningful, watching it, standing under the vastness of the sky and witnessing something so beautiful and so indifferent to human concerns. The cold of the winter night settles around you, creeping through layers of clothing, numbing fingers and toes. The air is still, or perhaps there is a slight breeze, carrying the scent of snow and ice. The ground is frozen, crunching underfoot, or covered in soft snow that muffles sound. Above, the stars are brilliant, brighter than they appear in warmer climates or closer to cities, each one a point of light against the black. And then there is the aurora, moving slowly across the northern sky, a curtain of green light that ripples and sways, brightening in some places and dimming in others, folding and unfolding in patterns that never quite repeat. The aurora can last for minutes or for hours. Sometimes it appears briefly and then fades away, the sky returning to darkness with only the stars remaining. Sometimes it continues through most of the night, active for hours on end, going through cycles of brightness and dimness, changing shape and position, keeping those who watch it entranced and reluctant to go inside even as the cold becomes uncomfortable. There is a feeling that if you look away, you might miss something, some particular moment of beauty that will not come again. But the aurora is generous with its beauty, offering moment after moment of shifting light, and eventually the cold wins, and you return to warmth, carrying the memory of what you saw. The memory of watching the aurora stays with people, becoming one of those experiences that is returned to again and again in thought. The details may blur over time, the exact colors and shapes may become less distinct, but the feeling remains, the sense of having witnessed something extraordinary, something that connected you to the larger universe in a direct and immediate way. The aurora is not a rare phenomenon in absolute terms, happening every night somewhere on Earth, but it is rare in personal experience for most people, something seen only once or a few times in a lifetime. And that rarity makes it precious, makes each viewing something to be cherished and remembered. The scientific instruments that measure the aurora record its intensity and spectrum, breaking down the light into its component wavelengths, tracking the variations over time, building up data that can be analyzed and compared with other measurements. These instruments provide valuable information about the state of the magnetosphere and the atmosphere, about the strength of the solar wind and the occurrence of geomagnetic storms. But they do not capture the subjective experience of watching the aurora, the aesthetic response to the light and motion, the quiet wonder that arises from seeing something so beautiful and so far beyond human control or influence. The Earth's magnetic field is slowly changing over time. The magnetic poles drift, moving gradually across the surface as the patterns of flow in the molten core shift and change. The North Magnetic Pole, which is different from the geographic North Pole, has been moving more quickly in recent decades than it did in previous centuries, drifting from northern Canada toward Siberia. This movement of the poles affects where the auroral oval is positioned, but the changes happen slowly, over years and decades, not something that would be noticed from one night to the next. The aurora will continue to appear near the magnetic poles wherever they drift to, as long as the Earth maintains its magnetic field. There are times when the aurora appears almost directly overhead, filling the entire sky from horizon to horizon. This is sometimes called a corona, though it has nothing to do with the sun's corona. The rays of the aurora appear to radiate from a single point high above, converging toward a central point due to perspective, like looking up at a cluster of tall trees that seem to lean toward each other even though they are all growing straight up. A corona is a spectacular sight, the curtains of light seeming to swirl around the observer, colors shifting and changing in all directions. It can create a sense of disorientation, of being surrounded by the aurora, enveloped in light. The atmosphere through which the aurora shines is a thin layer, compared to the size of the Earth. If the Earth were the size of an apple, the atmosphere would be thinner than the apple's skin. And yet this thin layer contains all the air we breathe, all the weather, all the clouds, and hosts the aurora in its highest reaches. Above the atmosphere is the near vacuum of space, where the solar wind flows unimpeded, where the magnetosphere extends its invisible protection, where satellites orbit and the moon circles the Earth. The aurora exists at the boundary between atmosphere and space, in a region where the air is too thin to breathe but still thick enough to glow when struck by particles from the sun. Looking at the aurora, it is easy to imagine it as something eternal and unchanging, a feature of the universe that has always existed and always will. But in cosmic terms, the aurora is a temporary phenomenon, dependent on conditions that are themselves temporary. The sun will not shine forever. In about 5 billion years, it will begin to run out of hydrogen fuel in its core and will start to change, expanding into a red giant star. The Earth's fate at that point is uncertain, but long before then, the sun's increasing luminosity will have made the Earth uninhabitable for life as we know it. The solar wind will continue to flow, perhaps even stronger than it is now, but there may be no atmosphere left to create an aurora, no observers to watch it. The aurora, like everything else, exists within the context of time, part of a story that has a beginning and will have an end, even if that end is unimaginably far in the future. But in the present moment, on a cold winter night, the aurora is here, glowing softly in the sky, moving through its patterns without hurry or urgency. The green light brightens, a curtain rippling from west to east, and then fades slightly, only to brighten again in a different location. A hint of purple appears at the lower edge, a brief flush of color that adds depth and variety to the display. The stars shine through the aurora, their light traveling for years and centuries and millennia to reach the Earth, passing through the auroral glow in the last tiny fraction of their journey. The moon may be up, casting its pale light across the snow, or it may be below the horizon, leaving the sky darker and the aurora more visible. Time passes, measured in breaths and heartbeats, in the slow drift of thoughts and the gradual numbing of cold. The aurora does not care whether anyone is watching. It appears and disappears according to the flow of particles and the state of the magnetosphere, indifferent to the presence or absence of observers. But for those who are watching, it becomes a shared experience, even when experienced alone. It joins them to all the others who have watched the aurora throughout history, from ancient peoples seeing it as spirits and signs, to early scientists trying to understand it, to modern observers who know the physics but still find it beautiful. The aurora is a point of connection across time and culture, a natural phenomenon that has inspired wonder and curiosity in every generation that has seen it. As the night deepens, the aurora may begin to quiet, the displays becoming less active, the curtains fading to a diffuse glow that spreads across the northern horizon. Or it may continue to dance, maintaining its activity through the hours until dawn begins to lighten the sky and the aurora becomes invisible against the growing daylight. The sun will rise, if it rises at all in the depths of winter in the far north, and the day will proceed in its ordinary way, and the aurora will be forgotten for a while, relegated to memory until the next clear night when conditions are right and it appears again. The Earth continues its orbit around the sun, moving through space at tremendous speed, though we feel no motion standing on its surface. The sun continues to shine, fusing hydrogen into helium in its core, releasing energy that streams out in all directions, some of it reaching Earth as light and heat and particles. The magnetic field continues to surround the Earth, generated by the churning of molten iron deep below the surface, invisible but always present, shaping the space environment around the planet. The aurora continues to appear, night after night in the polar regions, sometimes bright and sometimes dim, sometimes visible and sometimes hidden by clouds or overwhelmed by daylight. The cycle continues, as it has for billions of years, as it will for billions more, the slow steady rhythm of cosmic processes playing out on a scale that dwarfs human timescales and human concerns. The aurora is patient. It does not rush, does not force itself on the observer's attention, does not demand anything. It simply is, existing in its own time, moving at its own pace, offering its beauty to anyone who takes the time to look up and watch. In a world that often moves too quickly, that fills every moment with noise and activity and urgency, the aurora offers a different pace, a reminder that some things cannot be hurried, that some experiences require stillness and patience and a willingness to be present in the moment without distraction. The lights continue to move, shifting and changing, green curtains rippling across the sky, sometimes joined by hints of other colors, purple and pink and red, sometimes spreading wide across the horizon, sometimes concentrated in narrow bands that stretch from east to west. The patterns never repeat exactly, each moment bringing a slightly different configuration, a slightly different play of light and shadow against the darkness. The aurora is both predictable and unpredictable, following the laws of physics that govern the interaction of particles and magnetic fields and atmospheric gases, yet expressing those laws in ways that are endlessly varied and impossible to forecast in detail. Watching the aurora, you become aware of your own breathing, of the rise and fall of your chest, of the cold air entering your lungs and the warm air leaving them. You become aware of the stillness of your body, standing or sitting in one place, minimizing movement to avoid disturbing the experience. You become aware of the darkness surrounding you, the way it presses in from all sides except above, where the aurora glows. You become aware of time passing, marked not by clocks or schedules but by the gradual changes in the sky, by the shifting of the aurora, by the slow wheeling of the stars overhead. The aurora appears in paintings and photographs, in films and documentaries, in stories and poems. It has been used as a symbol of mystery and wonder, of the sublime beauty of nature, of the connection between Earth and cosmos. Artists have tried to capture its colors and movement, though no static image can fully represent the experience of watching it. Writers have tried to describe it, though words can only approximate the visual and emotional impact of seeing it in person. The aurora remains slightly beyond the reach of art and language, always exceeding attempts to fully capture or describe it, maintaining a quality of ineffability that is part of its appeal. The indigenous stories about the aurora often include elements of respect and caution, a recognition that this phenomenon, while beautiful, is also powerful and beyond human understanding or control. The spirits in the sky, whether of the dead or of animals or of other entities, were not to be trifled with, not to be approached carelessly or disrespectfully. The aurora was a reminder of the larger forces at work in the world, forces that existed before humans and would continue to exist after humans were gone. This understanding, embedded in stories passed down through generations, reflects a worldview that places humans within nature rather than above it, that recognizes the limits of human knowledge and control. The auroral oval shifts and pulses, expanding during geomagnetic storms and contracting during quiet periods, moving slightly with the changes in the solar wind and the Earth's rotation. Satellites in orbit can observe the entire oval at once, seeing it from above as a luminous ring around the magnetic pole, a perspective that is impossible from the ground. These satellite observations have provided valuable data about how the aurora responds to different conditions, about how quickly it can change and how far it can extend. But they do not replace the ground-based experience of watching the aurora, of being under it rather than above it, of seeing it against the backdrop of the horizon and the landscape rather than against the curve of the Earth from space. The night wears on, and the cold deepens, and still the aurora continues its slow dance. There is a timeless quality to the experience, a sense that this moment could be happening now or 100 years ago or 1,000 years ago, that the aurora is unchanging even as it constantly changes. The same light that shines down now has shone down on countless generations, seen by people who lived lives vastly different from ours, who understood it through different frameworks, who gave it different meanings. And yet the experience of wonder, of being moved by beauty, of feeling small in the face of something vast and indifferent, this experience may have been similar across all those generations, a shared human response to a natural phenomenon that transcends cultural and temporal boundaries. The magnetosphere flexes and bends under the pressure of the solar wind, like a sail filled with wind or a flag streaming in a breeze, though on a scale almost impossible to comprehend. The tail of the magnetosphere extends far into space, and within it, complex processes play out, particles being accelerated and redirected, energy being stored and released, magnetic field lines reconnecting in ways that send bursts of particles streaming toward the poles. These processes are studied by spacecraft that venture into the magnetosphere, measuring fields and particles, sending data back to Earth where it is analyzed and incorporated into models and theories. But the aurora remains the most visible manifestation of these processes, the part that can be seen with the naked eye from the ground, the tangible evidence of invisible cosmic interactions. The aurora might fade now, the curtains thinning and becoming more diffuse, the colors dimming to a pale glow that barely stands out against the darkness. Or it might brighten again, surging back to life in a new burst of activity, curtains forming and rippling across the sky with renewed vigor. The aurora has its own rhythms, its own cycles of activity and quiet, and they do not always align with human expectations or preferences. The aurora exists on its own terms, and we can only watch and appreciate what it offers when it offers it. In the far south, over Antarctica, the Aurora australis displays the same beauty as its northern counterpart, though it is witnessed by far fewer eyes. The penguins and seals pay it no attention, going about their lives in the darkness of the Antarctic winter without regard for the lights above. The researchers at scientific stations sometimes step outside to watch, when their work allows and the weather permits, adding their observations to the long history of human encounters with the aurora. The Aurora australis appears in the same colors, moves in the same patterns, follows the same physical processes as the aurora borealis. The two are twins, separated by the diameter of the Earth but otherwise identical in nature and cause. The aurora is a reminder that Earth is not isolated in space, that we are constantly bathed in radiation and particles from the Sun, that our planet's magnetic field is essential for maintaining the atmosphere and protecting life. It is a reminder that the Sun, despite appearing stable and unchanging from day to day, is actually a dynamic star with a complex magnetic field and periodic outbursts of activity. It is a reminder that the universe is full of interactions and connections, that nothing exists in isolation, that every object influences and is influenced by everything around it. The green light of the aurora comes from oxygen atoms at an altitude where the atmosphere is very thin, where the air pressure is thousands of times lower than at sea level. At this altitude, the atoms are so far apart that after being excited by a collision with a solar wind particle, they can take a full second or more to emit their photon of light. This slow emission is why the aurora appears to glow rather than flash, why it has a steady luminous quality rather than the rapid flickering of a fluorescent light. The atoms glow one at a time, individually, but there are so many of them being excited at any given moment that the overall effect is a steady curtain of light. Time continues to pass, though it is difficult to keep track of how long you have been standing here, watching the aurora. It might be minutes or hours, the cold making time feel both stretched and compressed, each moment distinct and yet blending together into a continuous experience. The sky is vast above you, the aurora occupying a portion of it, the stars filling the rest, the darkness extending in all directions. There is a sense of being very small, a tiny point of awareness in a vast universe, and yet also a sense of being connected to that universe, part of the same physical processes that create the aurora, made of the same atoms that were forged in stars, breathing the same atmosphere that glows with auroral light. The aurora is beginning to fade now, the curtains becoming less distinct, the green light dimming to a pale glow that merges with the background darkness. The display is ending, or at least this phase of it is ending, returning the sky to its usual state of stars and darkness. The memory of the aurora remains, vivid and immediate, but the aurora itself is departing, the particles from the solar wind perhaps decreasing in number, or the magnetosphere shifting in response to changing conditions, reducing the flow of particles into the atmosphere. The aurora does not announce its departure any more than it announced its arrival. It simply fades, gradually becoming fainter, until it is no longer visible, and the sky is left to the stars. You can go inside now, returning to warmth and light, carrying the memory of what you have seen. The aurora will appear again, tomorrow night or next week or next month, whenever conditions are right, whenever the solar wind is strong and the sky is dark and the clouds permit. It will continue to appear for as long as the sun shines and the earth has a magnetic field, a patient and indifferent display of natural beauty, waiting for the next observer to step outside and look up and witness its silent dance across the night sky. And perhaps you will be one of those observers again, returning to the cold and the darkness to watch the lights, to stand in stillness and let the aurora work its quiet magic, a reminder of the vast and beautiful universe in which we live, a reminder that there are still wonders to be found in the natural world, still moments of beauty that can stop us in our tracks and make us forget, for a little while, everything else except the shifting colors in the sky above.